The Fives by Ludwig Wittgenstein. Propositions are truth functions of elementary propositions. An elementary proposition is a truth function of itself. The elementary propositions are the truth arguments of propositions. It is natural to confuse the arguments of functions with the indices of names. For I recognize the meaning of the sign containing it from the argument just as much as from the index. In Russell's plus for cardinals, for example, C is an index, which indicates that the whole sign is the addition sign for cardinal numbers. But this way of symbolizing depends on arbitrary agreement, and one could choose a simple sign instead of plus sub C. But in not P, P is not an index, but an argument. The sense of not P cannot be understood unless the sense of P has previously been understood. In the name Julius Caesar, Julius is an index. The index is always part of a description of the object to whose name we attach it, e.g., the Caesar of the Julian gens. The confusion of argument and index is, if I am not mistaken, at the root of Frege's theory of the meaning of propositions and functions. For Frege, the propositions of logic were names, and their arguments the indices of these names. The truth functions can be ordered in series. That is the foundation of the theory of probability. The truth functions of every number of elementary propositions can be written in a schema of the following kind. If the truth function of P and Q is determined to be true, 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 then this truth function is a tautology, like if P then P, and if Q then Q. If the truth function of P and Q is determined to be false, true, 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 then this truth function in words is not both P and Q. If the truth function of P and Q is determined to be true, false, true, true, then this is determined to be if Q, then P. If the truth function of P and Q is determined to be true, true, false, true, then this truth function is determined to be if P, then Q. The truth function of P and Q is determined to be true, 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 false, then this is determined to be P or Q. If the truth function of P and Q is determined to be false, false, true, true, then this is not Q. If the truth function of P and Q is determined to be false, true, true, then this is not P. If the truth function of P and Q is determined to be false, true, false, then this is P or Q, but not both. If the truth function of P and Q is determined to be true, false, true, then this is if P, then Q, and if Q, then P, or P if and only if Q. If the truth function of P and Q is determined to be true, false, then this is P. If the truth function of P and Q is determined to be true, false, then this is Q. If the truth function of P and Q is determined to be false, true, then this is neither P nor Q. If the truth function of P and Q is determined to be false, true, false, then this is P and not Q. If the truth function of P and Q is determined to be false, true, false, then this is Q and not P. If the truth function of P and Q is determined to be true, false, then this is P and Q. If the truth function of P and Q is determined to be false, then this is a contradiction, P and not P, and Q and not Q. Those truth possibilities of its arguments which verify the proposition, I shall call its truth grounds. If the truth grounds, which are common to a number of propositions, are all also truth grounds of some one proposition, we say that the truth of this proposition follows from the truth of those propositions. In particular, the truth of a proposition P follows from that of a proposition Q if all the truth grounds of the second are truth grounds of the first. The truth grounds of Q are contained in those of P. P follows from Q. If P follows from Q, the sense of P is contained in that of Q. If a God creates a world in which certain propositions are true, he creates thereby also a world in which all propositions consequent on them are true. And similarly, he could not create a world in which the proposition P is true without creating all its objects. A proposition asserts every proposition which follows from it. P and Q is one of the propositions which assert P, and at the same time one of the propositions which assert Q. Two propositions are opposed to one another if there is no significant proposition which asserts them both. Every proposition which contradicts another denies it. That the truth of one proposition follows from the truth of other propositions we perceive from the structure of propositions. If the truth of one proposition follows from the truth of others, This expresses itself in relations in which the forms of these propositions stand to one another, and we do not need to put them in these relations first by connecting them with one another in a proposition, for these relations are internal and exist as soon as, and by the very fact that, the propositions exist. When we conclude from P or Q and not P to Q, the relation between the forms of the propositions P or Q and not P is here concealed by the method of symbolizing. But if we write, e.g., instead of P or Q, P is incompatible with Q is incompatible with P's incompatibility with Q, and instead of not P, P is incompatible with P is incompatible with P means neither P nor Q, then the interconnection becomes obvious. The fact that we can infer f of a from for all x f of x shows that the generality is present also in the symbol for all x f of x. If P follows from Q, I can conclude from Q to P, infer P from Q. The method of inference is to be understood from the two propositions alone. Only they themselves can justify the inference. Laws of inference, which, as in Frege and Russell, are to justify the conclusions, are senseless and would be superfluous. All inference takes place a priori. From an elementary proposition, no other can be inferred. In no way can an inference be made from the existence of one state of affairs to the existence of another entirely different from it. There is no causal nexus which justifies such an inference. The events of the future cannot be inferred from those of the present. Superstition is the belief in the causal nexus. The freedom of the will consists in the fact that future actions cannot be known now. We could only know them if causality were an inner necessity, like that of logical deduction. The connection of knowledge in what is known is that of logical necessity. A knows that P is the case is senseless if P is a tautology. If from the fact that a proposition is obvious to us, it does not follow that it is true, then obviousness is no justification for our belief in its truth. If a proposition follows from another, then the latter says more than the former less than the latter. If P follows from Q and Q from P, then they are one and the same proposition. A tautology follows from all propositions. It says nothing. Contradiction is something shared by propositions, which no proposition has in common with another. Tautology is that which is shared by all propositions, which have nothing in common with one another. Contradiction vanishes, so to speak, outside, tautology inside all propositions. Contradiction is the external limit of the propositions, tautology their substanceless center. If true sub r is the number of truth grounds of the proposition R, true sub r sub s the number of those truth grounds of the proposition S, which are at the same time truth grounds of R, then we call the ratio true sub rs to true sub r the measure of the probability which the proposition R gives to the proposition S. Suppose in a schema like that above, in number 5.101, true sub r is the number of the t's in the proposition R, true sub rs the number of those t's in the proposition S, which stand in the same columns as t's of the proposition R. Then the proposition R gives to the proposition S the probability of the ratio true sub rs to true sub r. There is no special object peculiar to probability propositions. Propositions which have no truth arguments in common with one another we call independent. Two elementary propositions give to one another the probability 1/2. If P follows from Q, the proposition Q gives to the proposition P the probability 1. The certainty of logical conclusion is a limiting case of probability. Application to tautology and contradiction. A proposition is in itself neither probable nor improbable. An event occurs or does not occur. There is no middle course. In an urn, there are equal numbers of white and black balls, and no others. I draw one ball after another and put them back in the urn. Then I can determine by the experiment that the numbers of the black and white balls which are drawn approximate as the drawing continues. So this is not a mathematical fact. If then, I say, it is equally probable that I should draw a white and a black ball, this means all the circumstances known to me, including the natural laws hypothetically probability assumed, give to the occurrence of the one event no more probability than to the occurrence of the other. That is, they give, as can easily be understood from the above explanations, to each the probability 1/2. What I can verify by the experiment is that the occurrence of the two events is independent of the circumstances with which I have no closer acquaintance. The unit of the probability proposition is, the circumstances with which I am not further acquainted give to the occurrence of a definite event such and such a degree of probability. Probability is a generalization. It involves a general description of a propositional form. Only in default of certainty do we need probability. If we are not completely acquainted with a fact, but know something about its form, a proposition can, indeed, be an incomplete picture of a certain state of affairs, but it is always a complete picture. The probability proposition is, as it were, an extract from other propositions. The structures of propositions stand to one another in internal relations. We can bring out these internal relations in our manner of expression by presenting a proposition as the result of an operation which produces it from other propositions, the bases of the operation. The operation is the expression of a relation between the structures of its result and its bases. The operation is that which must happen to a proposition in order to make another out of it. And that will naturally depend on their formal properties, on the internal similarity of their forms. The internal relation which orders a series is equivalent to the operation by which one term arises from another. The first place in which an operation can occur is where a proposition arises from another in a logically significant way, i.e., where the logical construction of the proposition begins. The truth functions of elementary proposition are results of operations which have the elementary propositions as bases. I call these operations truth operations. The sense of a truth function of P is a function of the sense of P. Denial, logical addition, logical multiplication, etc., are operations. Denial reverses the sense of a proposition. An operation shows itself in a variable. It shows how we can proceed from one form of proposition to another. It gives expression to the difference between the forms, and that which is common to the bases and the result of an operation is the bases themselves. The operation does not characterize a form, but only the difference between forms. The same operation which makes Q from P makes R from Q, and so on. This can only be expressed by the fact that P, Q, R, etc. are variables which give general expression to certain formal relations. The occurrence of an operation does not characterize the sense of a proposition, for an operation does not assert anything, only its result does, and this depends on the bases of the operation. Operation and function must not be confused with one another. A function cannot be its own argument, but the result of an operation can be its own basis. Only in this way is the progress from term to term in a formal series possible, from type to type in the hierarchy of Russell and Whitehead. Russell and Whitehead have not admitted the possibility of this progress, but have made use of it all the same. The repeated application of an operation to its own result I call its successive application. O applied to O applied to O applied to A is the result of the threefold successive application of O applied generally to Xi to A. In a similar sense, I speak of the successive applications of several operations to a number of propositions. The general term of the formal series A, O applied to A, O applied to O applied to A, etc., I write thus: A, X, O applied to X. This expression in brackets is a variable. The first term of the expression is the beginning of the formal series, the second the form of an arbitrary term of X of the series, and the third the form of that term in the series which immediately follows X. The concept of the successive application of an operation is equivalent to the concept, and so on. One operation can reverse the effect of another. Operations can cancel one another. Operations can vanish, e.g. denial in not P. Not P is identical with P. All propositions are results of truth operations on the elementary propositions. The truth operation is the way in which a truth function arises from elementary propositions. According to the nature of truth operations, in the same way as out of elementary propositions arise their truth functions, from truth functions arises a new one. Every truth operation creates from truth functions of elementary propositions another truth function of elementary propositions, i.e. a proposition. The result of every truth operation on the results of truth operations on elementary propositions is also the result of one truth operation on elementary propositions. Every proposition is the result of truth operations on elementary propositions. The schemata number 4.31 are also significant if P, Q, R, etc. are not elementary propositions. And it is easy to see that the propositional sign in number 442 expresses one truth function of elementary propositions even when P and Q are truth functions of elementary propositions. All truth functions are results of the successive application of a finite number of truth operations to elementary propositions. Here it becomes clear that there are no such things as logical objects or logical constants in the sense of Frege and Russell. For all those results of truth operations on truth functions are identical, which are one and the same truth function of elementary propositions. That or, implies, etc. are not relations in the sense of right and left, etc. is obvious. The possibility of crosswise definition of the logical primitive signs of Frege and Russell shows by itself that these are not primitive signs and that they signify no relations. And it is obvious that the implies, which we define by means of tilde and or, is identical with that by which we define or with the help of not, and that this or is the same as the first, and so on. That from a fact P an infinite number of others should follow, namely not P, not P, etc., is indeed hardly to be believed, and it is no less wonderful that the infinite number of propositions of logic, of mathematics, should follow from half a dozen primitive propositions. But all propositions of logic say the same thing, that is, nothing. Truth functions are not material functions. If, e.g., an affirmation can be produced by repeated denial, is the denial, in any sense, contained in the affirmation? Does not P deny not P, or does it affirm P, or both? The proposition not P does not treat of denial as an object, but the possibility of denial is already prejudged in the affirmation. And if there was an object called not, then not P would have to say that something other than P. For the one proposition would then treat of not, the other would not. The disappearance of the apparent logical constants also occurs if not there is an x such that not f of x says the same as for all x f of x, or there exists an x such that f of x and x is identical with a, the same as f of a. If a proposition is given to us, then the results of all truth operations which have it as their basis are given with it. If there are logical primitive signs, a correct logic must make clear their position relative to one another and justify their existence. The construction of logic out of its primitive signs must become clear. If logic has primitive ideas, these must be independent of one another. If a primitive idea is introduced, it must be introduced in all contexts in which it occurs at all. One cannot, therefore, introduce it for one context and then again for another. For example, if denial is introduced, we must understand it in propositions of the form not P, just as in propositions like not P or Q. Exists an x such that not f of x, and others. We may not first introduce it for one class of cases and then for another, for it would then remain doubtful whether its meaning in the two cases was the same, and there would be no reason to use the same way of symbolizing in the two cases. In short, what Frege, Grundgesetze der Arithmetik, has said about the introduction of signs by definitions holds, mutatis mutandis, for the introduction of primitive signs also. The introduction of a new expedient in the symbolism of logic must always be an event full of consequences. No new symbol may be introduced in logic in brackets or in the margin, with, so to speak, an entirely innocent face. Thus, in the Principia Mathematica of Russell and Whitehead, there occurred definitions and primitive propositions in words. Why suddenly words here? This would need a justification. There was none, and can be none, for the process is actually not allowed. But if the introduction of a new expedient has proved necessary in one place, we must immediately ask, where is this expedient always to be used? Its position in logic must be made clear. all numbers in logic must be capable of justification. Or rather, it must become plain that there are no numbers in logic. There are no preeminent numbers. In logic, there is no side-by-side. There can be no classification. In logic, there cannot be a more general and a more special. The solution of logical problems must be neat, for they set the standard of neatness. Men have always thought that there must be a sphere of questions whose answers, a priori, are symmetrical and united in a closed, regular structure, a sphere in which the proposition simplex sigillum veri is valid. When we have rightly introduced the logical signs, the sense of all their combinations has been already introduced with them. Therefore, not only P or Q, but also not P or not Q, etc., etc. We should then already have introduced the effect of all possible combinations of brackets, and it would then have become clear that the proper general primitive signs are not P or Q, there exists an X such that f of x, etc., but the most general form of their combinations. The apparently unimportant fact that the apparent relations like or and not need brackets, unlike real relations, is of great importance. The use of brackets with these apparent primitive signs shows that these are not the real primitive signs, and nobody, of course, would believe that the brackets have meaning by themselves. Logical operation signs are punctuations. It is clear that everything which can be said beforehand about the form of all propositions at all can be said on one occasion, for all logical operations are already contained in the elementary proposition. For f of a says the same as there exists an x such that f of x and x is identical with a. Where there is composition, there is argument and function, and where these are, all logical constants already are. One could say the one logical constant is that which all propositions, according to their nature, have in common with one another. That, however, is the general form of proposition. 5.471. The general form of proposition is the essence of proposition. To give the essence of proposition means to give the essence of all description, therefore, the essence of the world. The description of the most general propositional form is the description of the one and only general primitive sign in logic. Logic must take care of itself. A possible sign must also be able to signify everything which is possible in logic is also permitted. Socrates is identical means nothing because there is no property which is called identical. The proposition is senseless because we have not made some arbitrary determination, not because the symbol is in itself unpermissible. In a certain sense, we cannot make mistakes in logic. Self-evidence, of which Russell has said so much, can only be discarded in logic by language itself preventing every logical mistake. That logic is a priori consists in the fact that we cannot think illogically. We cannot give a sign the wrong sense. Occam's razor is, of course, not an arbitrary rule, nor one justified by its practical success. It simply says that unnecessary elements in a symbolism mean nothing. Signs which serve one purpose are logically equivalent. Signs which serve no purpose are logically meaningless. Frege says, every legitimately constructed proposition must have a sense. And I say, every possible proposition is legitimately constructed, and if it has no sense, this can only be because we have given no meaning to some of its constituent parts, even if we believe that we have done so. Thus, Socrates is identical says nothing, because we have given no meaning to the word identical as adjective, for when it occurs as the sign of equality, it symbolizes in an entirely different way. The symbolizing relation is another. Therefore, the symbol is in the two cases entirely different. The two symbols have the sign in common with one another only by accident. The number of necessary fundamental operations depends only on our notation. It is only a question of constructing a system of signs of a definite number of dimensions, of a definite mathematical multiplicity. It is clear that we are not concerned here with a number of primitive ideas which must be signified, but with the expression of a rule. Every truth function is a result of the successive application of the operation ... true, psi, and so on, to elementary propositions. This operation denies the propositions in the right-hand bracket, and I call it the negation of those propositions. An expression in brackets whose terms are propositions I indicate, if the order of the terms in the bracket is indifferent, by a sign of the form xi bar. Xi is a variable whose values are the terms of the expression in brackets, and the line over the variable indicates that it stands for all its values in the bracket. Thus, if xi has the three values p, q, r, then xi bar is identical to p, q, r. The values of the variable must be determined. The determination is the description of the propositions which the variable stands for. How the description of the terms of the expression in brackets takes place is unessential. We may distinguish three kinds of description. Direct enumeration. In this case, we can place simply its constant values instead of the variable. 2. Giving a function f of x whose values for all values of x are the propositions to be described. 3. Giving a formal law according to which those propositions are constructed. In this case, the terms of the expression in brackets are all the terms of a formal series. Therefore, I write instead of dash 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 true of xi and so on, n of xi bar. N of xi bar is the negation of all the values of the propositional variable xi. As it is obviously easy to express how propositions can be constructed by means of this operation, and how propositions are not to be constructed by means of it, this must be capable of exact expression. If xi has only one value, then n of xi bar is identical to not p. If it has two values, then n of xi bar is identical to not p and not q, or neither p nor q. How can the all-embracing logic which mirrors the world use such special catches and manipulations? Only because all these are connected into an infinitely fine network, to the great mirror. Not p is true if p is false. Therefore, in the true proposition, not p, p is a false proposition. How then can the stroke, tilde, bring it into agreement with reality? That which denies in not p is, however, not tilde, but that which all signs of this notation, which deny p, have in common. Hence the common rule according to which not p, not p, not p or not p and not p, etc., to infinity, are constructed, and this which is common to them all mirrors denial. We could say what is common to all symbols which assert both p and q is the proposition p and q. What is common to all symbols which assert either p or q is the proposition p or q. And similarly, we can say two propositions are opposed to one another when they have nothing in common with one another. And every proposition has only one negative, because there is only one proposition which lies altogether outside it. Thus, in Russell's notation, also, it appears evident that q and p or not p says the same as q, that p or not p says nothing. If a notation is fixed, there is in it a rule according to which all the propositions denying p are constructed, a rule according to which all the propositions asserting p are constructed, a rule according to which all the propositions asserting p or q are constructed, and so on. These rules are equivalent to the symbols, and in them their sense is mirrored. It must be recognized in our symbols that what is connected by or, and, etc. must be propositions. And this is the case for the symbols p and q presuppose or, not, etc. If the sign p in p or q does not stand for a complex sign, then by itself it cannot have a sense. But then also the signs p or p, p and p, etc., which have the same sense as p, have no sense. If, however, p or p has no sense, then also p or q can have no sense. Must the sign of the negative proposition be constructed by means of the sign of the positive? Why should one not be able to express the negative proposition by means of a negative fact? Like, if A does not stand in a certain relation to B, it could express that A R B is not the case. But here also the negative proposition is indirectly constructed with the positive. The positive proposition must presuppose the existence of the negative proposition, and conversely. If the values of xi are the total values of a function f of x for all values of x, then n of xi bar is identical to not that there exists an x such that f of x. I separate the concept all from the truth function. Frege and Russell have introduced generality in connection with the logical product or the logical sum. Then it would be difficult to understand the propositions there is an x such that f of x, and for all x, f of x, in which both ideas lie concealed. That which is peculiar to the symbolism of generality is, firstly, that it refers to a logical prototype, and secondly, that it makes constants prominent. The generality symbol occurs as an argument. If the objects are given, therewith are all objects also given. If the elementary propositions are given, then therewith all elementary propositions are also given. It is not correct to render the proposition there is an x such that f of x as Russell does. In words, f of x is possible. Certainty, possibility, or impossibility of a state of affairs are not expressed by a proposition, but by the fact that an expression is a tautology, a significant proposition or contradiction. That precedent, to which one would always appeal, must be present in the symbol itself. One can describe the world completely by completely generalized propositions, i.e., without from the outset coordinating any name with a definite object. In order, then, to arrive at the customary way of expression, we need simply say, after an expression, there is one and only one x which, and so on, and this x is A. A completely generalized proposition is like every other proposition composite. This is shown by the fact that in there exists an x and a phi such that phi of x, we must mention phi and x separately. Both stand independently in signifying relations to the world as in the ungeneralized proposition. A characteristic of a composite symbol: it has something in common with other symbols. The truth or falsehood of every proposition alters something in the general structure of the world, and the range which is allowed to its structure by the totality of elementary propositions is exactly that which the completely general propositions delimit. If an elementary proposition is true, then, at any rate, there is one more elementary proposition true. Identity of the object I express by identity of the sign, and not by means of a sign of identity. Difference of the objects by difference of the signs. That identity is not a relation between objects is obvious. This becomes very clear if, for example, one considers the proposition for all x, f of x implies x is identical with A. What this proposition says is simply that only A satisfies the function f, and not that only such things satisfy the function f which have a certain relation to A. One could of course say that in fact only A has this relation to A, but in order to express this, we should need the sign of identity itself. Russell's definition of identity won't do, because according to it, one cannot say that two objects have all their properties in common. Even if this proposition is never true, it is nevertheless significant. Roughly speaking, to say of two things that they are identical is nonsense, and to say of one thing that it is identical with itself is to say nothing. I write, therefore, not f of A and B and A is identical with B, but f of A and A, or f of B and B, and not f of A and B and A is not identical with B, but f of A, B. And analogously, not there is an x and a y such that f of x and y and x is identical with y, but there exists an x such that f of x and x, and not there exists an x and a y such that f of x and y and x is not identical to y, but there exists an x and a y such that f of x and y. Therefore, instead of Russell's exists an x and there exists a y such that f of x and y, and there exists an x and a y such that f of x and y, or there exists an x such that f of x and x. Instead of for all x, f of x implies x is identical with A, we therefore write, e.g., there exists an x such that f of x and f of A, and it's not the case that there is an x and a y such that f of x and f of y. And the proposition only one x satisfies f reads, there exists an x such that f of x, and it's not the case that there exists an x and a y such that f of x and f of y. The identity sign is therefore not an essential constituent of logical notation. And we see that apparent propositions like A is identical with A is identical with B, and B is identical with C implies A is identical with C. For all x is identical with x, there exists an x such that x is identical with A, etc., cannot be written in a correct logical notation at all. So all problems disappear which are connected with such pseudo-propositions. This is the place to solve all the problems which arise through Russell's axiom of infinity. What the axiom of infinity is meant to say would be expressed in language by the fact that there is an infinite number of names with different meanings. There are certain cases in which one is tempted to use expressions of the form A is identical with A or P implies P, as for instance when one would speak of the archetype, proposition, thing, etc. So Russell in the Principles of Mathematics has rendered the nonsense P is a proposition in symbols by P implies P, and has put it as a hypothesis before certain propositions to show there are places where arguments could only be occupied by propositions. It is nonsense to place the hypothesis P implies P before a proposition in order to ensure that its arguments have the right form, because the hypothesis for a non-proposition as argument becomes not false but meaningless, and because the proposition itself becomes senseless for arguments of the wrong kind, and therefore it survives the wrong arguments no better and no worse than the senseless hypothesis attached for this purpose. Similarly, it was proposed to express there are no things by it is not the case that there exists an x such that x is identical with x. But even if this were a proposition, would it not be true if indeed there were things, but these were not identical with themselves? In the general propositional form, propositions occur in a proposition only as bases of the truth operations. At first sight, it appears as if there were also a different way in which one proposition could occur in another, especially in certain propositional forms of psychology, like A thinks that P is the case, or A thinks P, etc. Here it appears superficially as if the proposition P stood to the object A in a kind of relation, and in modern epistemology, Russell, Moore, etc., those propositions have been conceived in this way. But it is clear that A believes that P, A thinks P, A says P, are of the form that P says P. And here we have no coordination of a fact and an object, but a coordination of facts by means of a coordination of their objects. This shows that there is no such thing as the soul, the subject, etc., as it is conceived in contemporary superficial psychology. A composite soul would not be a soul any longer. The correct explanation of the form of the proposition A judges P must show that it is impossible to judge a nonsense. Russell's theory does not satisfy this condition. To perceive a complex means to perceive that its constituents are combined in such and such a way. This perhaps explains the figure, the Necker cube, can be seen in two ways as a cube, and all similar phenomena, for we really see two different facts. If I fix my eyes first on the corners A and only glance at B, A appears in front and B behind, and vice versa. We must now answer a priori the question as to all possible forms of the elementary propositions. The elementary proposition consists of names. Since we cannot give the number of names with different meanings, we cannot give the composition of the elementary propositions. Our fundamental principle is that every question which can be decided at all by logic can be decided offhand. And if we get into a situation where we need to answer such a problem by looking at the world, this shows that we are on a fundamentally wrong track. The experience which we need to understand logic is not that such and such is the case, but that something is. But that is no experience. Logic precedes every experience. That something is so. It is before the how, not before the what. And if this were not the case, how could we apply logic? We could say, if there were a logic, even if there were no world, how then could there be a logic, since there is a world? Russell said that there were simple relations between different numbers of things, individuals. But between what numbers? And how should this be decided? By experience? There is no preeminent number. The enumeration of any special forms would be entirely arbitrary. How could we decide a priori whether, for example, I can get into a situation in which I need to symbolize with the sign of a 27-termed relation? May we then ask this at all? Can we set out a sign form and not know whether anything can correspond to it? Has the question sense? What must there be in order that anything can be the case? It is clear that we have a concept of the elementary proposition apart from its special logical form. Where, however, we can build symbols according to a system, there this system is the logically important thing, and not the single symbols. And how would it be possible that I should have to deal with forms in logic which I can invent? But I must have to deal with that which makes it possible for me to invent them. There cannot be a hierarchy of the forms of the elementary propositions. Only that which we ourselves construct can we foresee. Empirical reality is limited by the totality of objects. The boundary appears again in the totality of elementary propositions. The hierarchies are and must be independent of reality. If we know on purely logical grounds that there must be elementary propositions, then this must be known by everyone who understands propositions in their unanalyzed form. All propositions of our colloquial language are actually, just as they are, logically completely in order. That simple thing which we ought to give here is not a model of the truth, but the complete truth itself. Our problems are not abstract, but perhaps the most concrete that there are. The application of logic decides what elementary propositions there are. What lies in its application, logic cannot anticipate. It is clear that logic may not conflict with its application, but logic must have contact with its application. Therefore, logic and its application may not overlap one another. If I cannot give elementary propositions a priori, then it must lead to obvious nonsense to try to give them. The limits of my language mean the limits of my world. The logic fills the world. The limits of the world are also its limits. We cannot therefore say in logic, this and this there is in the world, that there is not. For that would apparently presuppose that we exclude certain possibilities, and this cannot be the case, since otherwise logic must get outside the limits of the world, that is, if it could consider these limits from the other side also. What we cannot think, that we cannot think. We cannot therefore say what we cannot think. This remark provides a key to the question, to what extent solipsism is a truth. In fact, what solipsism means is quite correct, only it cannot be said, but it shows itself. That the world is my world shows itself in the fact that the limits of the language which I understand, mean the limits of my world. The world and life are one. I am my world, the microcosm, the thinking, presenting subject. There is no such thing. If I wrote a book, The World as I Found It, I should also have therein to report on my body and say which members obey my will and which do not, etc. This then would be a method of isolating the subject, or rather of showing that in an important sense there is no subject. That is to say, of it alone in this book mention could not be made. The subject does not belong to the world, but it is a limit of the world. Wherein the world is a metaphysical subject to be noted. You say that this case is altogether like that of the eye and the field of sight, but you do not really see the eye. And from nothing in the field of sight can it be concluded that it is seen from an eye. For the field of sight has not a form like this, where the eye is included in the visual field. This is connected with the fact that no part of our experience is also a priori. Everything we see could be otherwise. Everything we can describe at all could also be otherwise. There is no order of things a priori. Here we see that solipsism, strictly carried out, coincides with pure realism. The eye in solipsism shrinks to an extensionless point, and there remains the reality coordinated with it. There is, therefore, really a sense in which, in philosophy, we can talk of a non-psychological I. The I occurs in philosophy through the fact that the world is my world. The philosophical I is not the man, not the human body or the human soul of which psychology treats, but the metaphysical subject, the limit, not a part, of the world.